So we know how to graph the inverses. Don't forget, when you're using inverse trig functions, sine, cosine, tangent, you're finding the angle measure. Okay, so we're finding either degrees or radians, whatever has been specified, whatever we need to be looking for. On your calculator, so if you need to, pause the video and get your calculator out because you need to practice this. There is an inverse function, and if you have a graphing calculator, even if you have scientific, it's the second function for sine, cosine, tangent. So what I'm going to do is I'm going to take the inverse sine and apply that to negative 0.13. Okay, and if I'm rounding, because the directions say to round to 2 decimal places, I'm going to get approximately negative 7.47. Okay, for 1 over 8, if I take the inverse cosine, I'm going to get approximately 82.82. And then if I take rad 3 over 5 and apply the inverse tangent, we're going to get approximately 19.11. Okay, all inverses on your calculator. We need to be able to find the inverse using exact values. Now, remember, we saw with graphing that there are some restrictions. Inverse sine is restricted from negative pi over 2 to pi over 2. Okay, inverse cosine is restricted from 0 to pi. And then inverse tangent, its function is restricted the same as sine. The reason this is important is because as we travel around the unit circle, there are 2 places where you could get values. Because, for example, tangent is positive in the first and the third quadrant, but if I'm solving for the inverse, I need to follow that tangent is restricted in these 2 quadrants. Okay, and I'll color coordinate because that might be easier for us to see. Cosine goes all the way around, and then tangent is here also. The third quadrant is never spoken of. Okay, so the inverse sine of 1. Well, I know that sine is 1 at, yes, good, at pi over 2. So this is going to equal pi over 2 as its exact value. For b, 1/2. Well, gosh, I've got 2 options. I could be at pi over 6. I could be at 5 pi over 6. But because of the restrictions, I know that this is only going to refer to pi over 6. That's where I would see it on my graph. For the inverse cosine, oh, some of you are wondering where I got this information. Ladies and gentlemen, the unit circle. Okay, that's why I made you, or hopefully made you, asked you, begged you to memorize your unit circle. So as we're getting back into the swing of things, have your unit circle out. If you need to, print out another blank one and refresh your memory on what values are where and what the patterns are. Okay, so cosine of negative rad 2 over 2, it's negative. So right away I know I'm looking at the second quadrant. And for rad 2 over 2, I know that it refers to pi over 4, but cosine is negative, so that means that this is going to be 3 pi over 4. Inverse cosine of 0, there's only one option for that. Good, yep, I heard some of you. I can hear you. At pi over 2. Okay, inverse tangent. Okay, remember that the tangent of theta is equal to sine of theta over cosine of theta. Well, sine and cosine are the same at pi over 4, and that means that their tangent is 1. But there's 2 that we haven't seen in a while. So first is 30 degrees, so pi over 6. And the sine of pi over 6 is 1/2. Okay, pen, where'd you go? Ah! And the cosine is rad 3 over 2. So if we were to divide this 1/2, keep change flip because we're dividing fractions, we would end up with 1 over rad 3, and then when we rationalize, we get rad 3 over 3. Well, right away we know that that's our answer. But let's go ahead and do the other one we haven't seen in a while, so you have it on your notes, which is pi over 3. The sine of pi over 3 is rad 3 over 2. The cosine is 1/2, so we would have rad 3 over 2 times 2 over 1. So the tangent of pi over 3 is rad 3. Okay, those two we tend to not be as familiar with because it takes a little bit more effort, a little bit more memorization on our part. So if tangent's positive, we're in the first quadrant. That means that this is going to be pi over 6. And then we just talked about this. Oh, I gave it away. Inverse tangent of 1 is going to be pi over 4. Because again, we're in the first quadrant and pi over 4 tangent is 1. Okay, so remember the restrictions. Now, if we are composing a function within a function, work from the inside out. Okay, and this is to find the exact value. So the first thing I'm going to do is look at my sine of pi over 8. If I'm on a Cartesian coordinate plane, this is 0, and this is normally pi, which if I change it to a denominator of 8, would be 8 pi over 8. So this being pi over 2, if I convert it, would be 4 pi over 8, which means pi over 8 is right here. Sine does exist in the first quadrant for the inverse functions. Okay, so sine of pi over 8 gives us some angle measure. Okay, and if I were to draw the triangle in the first quadrant, it would look like that. Okay, so then we have the inverse sine of theta. Theta exists right here. We just drew it in the first quadrant. We figured that out. Now the inverse sine of theta, well, wait a minute. I'm just working backwards now, would be pi over 8. If you have a trig function inverse applied to its original and vice versa, they end up canceling it out as long as you can take the inverse sine of that value. Okay, if we look at b, well, inside first, we can absolutely figure out what the cosine of 5 pi over 6 is. It's in the second quadrant. We know this to be true. Cosine is negative in the second quadrant. So then we would have cosine inverse of negative rad 3 over 2, which we then again can figure out would be 5 pi over 6. They end up canceling each other out, and we're working back into circles. Now, the reason I didn't have a specific angle measure on A is because I don't know what the sine of pi over 8 is off the top of my head, and I don't want to approximate. I know that it's going to give me some angle measure in a triangle located in the first quadrant, so I just named it theta. Okay? A little bit abstract for us, I understand. It's okay. Okay, so the inverse cosine of 0.2. Well, let's see. I know that cosine and sine, right? So the cosine of theta can't be anything greater than 1. And that's because the cosine is adjacent over hypotenuse. Hypotenuse is the largest side. So there's no way for cosine or sine values to the ratio of the sides to be larger than 1. Since 0.2 is 2/10 or 1/5, it's not greater than 1. So these guys are going to cancel each other out, and we're just going to be left with 0.2. All right. I think, we've got just a few more. Hang there with me. Tangent of 7 pi over 5. Okay. So if I'm at 0 and I'm at pi, and my denominator is 5, that means that this is 5 pi over 5. Okay, we're trying to figure out what this angle, or where this angle might be. Okay, if I'm at 3 pi over 2, man, then you have to multiply by 2/5. We don't even need that. We can see that this would be about 2.5 pi over 5, because it's halfway around. So that means this would be about 7.5 pi over 5. 7 pi over 5 is going to be right about here. So 7 pi over 5 would be in the third quadrant. If we were to draw that triangle as such in the third quadrant, AST, T would be positive. Okay, so this is going to give us some angle theta. Now, tangent is not restricted. Its domain is not restricted in the third quadrant. It's restricted in the second, but it would have the same reference angle, just like we saw with the 30, 60, 90s and the 45, 45, 90 as we traveled around the unit circle. Okay, so if I'm 2 pi away, that means I'm going to have to be 2 pi away, because that relates to our reference angle. So the tangent of theta is going to end up equaling 2 pi over 5 because of the restrictions. 7 pi over 5 we deduced was in the third quadrant. Tangent is restricted to the first and the fourth quadrant. Since tangent is positive in our third quadrant, that means that I'm going to have to find theta in my first quadrant. And we went from there. Nice. Oh, so good. So good. Okay, so, oh, wait a minute. Can I find an angle measure that gives me a cosine value of 2? No, because we just talked about that. Cosine and sine cannot be or cannot have side ratios greater than 1. Why? Because their side ratios have a hypotenuse in the denominator. That is the largest side. That can never be greater than 1. Yes, good. Same thing here. These are not defined. These are not possible. Nice. Okay, so let's do a little bit more fun stuff. For example number 4, it says find the inverse function and then find the range in the domain. Okay, so going back to our inverse days, if we had to find the inverse of a given function, we rewrote f of x as y, and then we switched the x and y values. I'm going to use a different color. We switched the x and y values because by definition, and you guys saw this when we were graphing, the x and y values switch. The domain and range values switch. Okay, so I'm going to write f of x as y, and then I'm going to switch x and y. So x is equal to 3 times the cosine of y plus 1, and then I'm going to solve. I'm going to isolate. So the first thing I'm going to do is subtract 1 to both sides. So we have 3 times the cosine of y is equal to x minus 1. Divide by 3. So the cosine of y is equal to, and I'm actually going to multiply by the reciprocal. You can distribute, you don't have to. It doesn't matter. It's the same answer. And then I need to get y by itself. So my y inverse, I'm going to apply the inverse cosine. And there is our inverse. Okay, so we found the inverse function. It says find the range of f and the domain and range of f inverse. The reason being is because the domain is already given to us. Okay, so the domain, we're told, is between 0 and pi, which we know for the inverse is normally true. Sorry, for the original is normally true. And then the range for this guy, oh man, there's transformation. So we can't say it goes from -1 to 1. There's a vertical shift, and there is a vertical stretch. So what we do in this case is we solve the original. There we go. We're going to solve it for x. Cosine of x equals what in terms of y? Because the range is the y. So if I can take cosine of x as my original function and isolate it, it looks like this. So 3 cosine of x is equal to y minus 1. That's an equal sign. And then the cosine of x is equal to y minus 1 over 3. So the original function of cosine of x, its range, we subtracted 1 and then divided the whole quantity by 3. That's ultimately what it's saying. Normally, the range of cosine goes from -1 to 1. So I can, since I've isolated the cosine of x, just substitute that value in and solve for y to find what my new range restrictions are. Kind of fancy, right? I'm going to multiply both sides by 3, so we get y minus 1 is less than or equal to 3, -3, and then add 1 to both sides. So the new range is restricted between -2 and 4. Inclusive because it's cosine. So there's the f, the original function, domain, and range. And then down here, I'll go ahead and, how do we find that though? That's right. Inverse functions, the domain and range values switch. So the domain goes from -2 to 4, and the range would exist from 0 to pi. Very nice, guys. Very nice. Okay. Well, let's do tangent, and then we'll do one that's sine. Okay, there we go. So first thing I'm going to do is find the inverse. So I'm going to switch the x and y. And I'm going to solve for y because we're trying to find the inverse function. So add 3 to both sides. 2 tangent y is equal to x plus 3. Tangent of y is equal to 1/2 times x plus 3. Divide by 2 or multiply by its reciprocal. And then we take the inverse. So y inverse is equal to inverse tangent of 1/2 times the quantity of x plus 3. So there's our inverse function. Now for the original, we know that tangent is restricted in the first and the fourth quadrant. They've already given us, oh fudge, they've already given us that for the domain. I forgot to write D. There we go. And then what's the range for, very good, it's going to be all real numbers. Now, we don't have to go through this whole process of restricting the range because our tangent function isn't oscillating back and forth between 1 and -1. It's shooting off to infinity and negative infinity. So we can say that the inverse function has a domain of negative infinity to positive, and its range is the restricted non-inclusive negative pi over 2. Oopsies. To pi over 2. There we go. Okay, so since we've seen cosine and tangent, I want to at least expose you guys to sine. Okay, so for our sine, we have 3 times the sine of 2x. All right, so I'm going to find the inverse, which means I'm going to switch the x and y and solve for y. So we have the sine of 2y is equal to x over 3. It's 1/3 times x. And then I'm going to take the inverse of sine, because it's the only way that I'm going to be able to move sine to the other side. 1/3 x, if that's better for you guys. And then I'm going to divide by 2. So the inverse function is 1/2 inverse sine of 1/3 x. Sweet. Okay, so we know for the given that the domain, and it's restricted for us, is now going from negative pi over 4, and it could vary because we do have that horizontal compression. So that's why we're seeing, since b is 2, it's not pi over 2 anymore, it's pi over 4. Okay, that's why it's changing. But we have to find the range. So normally, we know that sine goes from -1 to 1, right? But we do have, good, we've got a vertical stretch. So what I'm going to do is I'm going to take, let's see, I shouldn't have done that over there. Y is equal to 3 times the sine of 2x. And I'm going to solve it for y. What? Solve it for sine of 2x. Just like I did up here with cosine. Yeah, if I can solve my function for the cosine of x, that parent function's range goes from 1 to -1, or -1 to 1. Now, I didn't necessarily solve for sine of x. I solved for sine of 2x. But the 2 is a horizontal, very good, a horizontal compression. So is that going to have an effect on my range? No. If there is a b value, the b value doesn't affect the range. Does not, nope, that's an A, affect the range. Good. So I'm just going to put the sine of 2, or sorry, y over 3 over here. Well, okay, so the sine of 2x, and then we can substitute y over 3 like we did for cosine. I'm going to multiply both sides by 3, so our new range is -3 to 3, inclusive, because it's sine. Okay, so then that means that for the inverse, your domain is now -3 to 3 inclusive, and your range is negative pi over 4 to pi over 4. I know it may bother you that for some of you, but wait, there's a 2 in front of my x. Yep, and that's accounted for in the restricted domain that was given at the beginning. Oh, rad, I love these. Okay, for these, I think you guys will be okay. because it's very similar to example 2. Just isolate. So the inverse cosine of x is going to be pi over 4. Where is cosine pi over 4? Yes. So if I were to rewrite this, that would be that x is equal to the cosine of pi over 4. That looks better. I wasn't happy with that, which is rad 2 over 2. For this guy, we would have the inverse tangent of x is equal to negative pi over 4. So yes, we are working, holy moly, it's pouring down rain. We are working in reverse from what we saw earlier. So x is the tangent of negative pi over 4, which means we're in the fourth quadrant, which means that it is, very good, negative 1. Okay, and then for this guy, I'll do that as a challenge, see if you can find it. Okay, there is something on here that you guys need to know how to do. It's super simple. This is our last example. I want to make sure that I get the wording right for you. So it says nope. Stick with me. Okay, there it is. Right. Oh, no, come back. Nope, definitely not what you need. Go away. Okay. It says write the trigonometric expression. So write this with me, you guys. The trigonometric expression as an algebraic expression in U. Not Y-O-U. U. So the first one that we're going to do is cosine of the inverse tangent of U. So, okay, what the directions mean is that I want you to solve this, find the trigonometric expression, but leave the variable U. Don't try to change it. Don't try to manipulate anything other than what's given. Okay, so for this guy, this is going to be some theta. So we know right away that the inverse tangent is going to give us some angle measure. Well, where does that exist? Tangent is positive. U is positive. So I'm going to be in the first quadrant. This is what our right triangle looks like in the first quadrant. And tangent is opposite over adjacent. So that means opposite over adjacent. How did I know that was a 1? Every integer has a 1 in the denominator, but we don't write it because there's no need. Yep, so it's 1. And then we're going to use u squared plus 1 squared is equal to c squared, because that's our hypotenuse. So our hypotenuse is just the square root of u squared plus 1. Yes, it's that simple, and you thought it was scary. Okay, so then the cosine is adjacent over hypotenuse, so it's 1 over the square root of u squared plus 1, and I'm not going to make you rationalize. Okay? Yeah, it's very straightforward. Let's do another one. Remember, what we do is we have to figure out where this triangle is going to be drawn. Draw in the triangle. Use the Pythagorean theorem to generate the rest of what we don't know. Okay, cotangent. Inverse cotangent is u, which means it's positive, which again means we're in the first quadrant. Disclaimer, triangle not drawn to scale. Okay, so then this would be the sine of theta. Inverses give you an angle measure. Degree or radian, doesn't matter. We know that cotangent is adjacent over opposite. It's the reciprocal of tangent. And again, we're going to have to use the Pythagorean theorem to find the hypotenuse, which it works out to be the same as our first example. Okay. Sine is opposite over hypotenuse. How funny is this? So we get the same answer. That's funny. Haha, chuckle, chuckle. Okay, very straightforward. Don't rationalize. I mean, rationalize if you want to, but you don't have to in my book. All right? Excellent. Thanks, guys.